Hello. Today we're going to learn about limits and how to solve limits. Okay? What is limit? Well, the basic definition of a limit is that it is a value that a function approaches as an input approaches the same value. For example, here we have a function, right? I graphed it. We have a function f of x. As x, the input that I'm going to put in, as this approaches some value, let's say 2, what does the function value output approach? Well, if you put it into that, we know it approaches 3, right? So yeah, and that's basically what it is. As x, the input value, approaches infinitely closer to 2, the f of x value will also approach infinitely closer to 2. So if I took a value really close to 2, like let's say I took 1.999999 and go on, as a result, if you do it, I would get 2.999999, and that is incredibly close to 3, right? But that's not exactly 3, because mainly we're not using the number itself, right? That's basically what limits are, alright? We're going to go infinitely closer to the value. Alright, in limits we basically observe that what would happen as the input, what would happen to the function as the input comes extremely close to a value. Alright? So as x comes to 2, what happens to the function? What's the output, alright? What's the output as x becomes 2? Alright, what comes up, alright? That's basically what a limit is. Okay? Now, the x, you can say it like this. I mean, you could say x approaches 2 with an arrow, and then f of x approaches 3, but that's not the correct way to write a limit, alright? Alright? The correct way to write a limit is that we say lim, right? And then underneath it, we say the input, the value that's gonna approach, that's the input that's gonna approach the value. So if, in this instance, x is gonna approach some value, let's say 2, alright? In the function, then we write the function here. X plus 1 is the function, right? Then we write what's the output of the function. What output is it getting closer to? As x approaches 2 in the function x plus 1, what does the function output become? Alright? What does it become? Now we can just easily substitute it in and find out, which in this case would just be 3. So basically what this says is as x approaches the function, as x approaches the value 2 in the function x plus 1, the function output approaches the value 3. Okay? Okay. Now, let's solve some problems with this. Right? Let's solve some problems. There's 2 ways to solve the function of this. Okay? There's 2 ways. I mean, there's no 2 ways. There's no 2 ways, okay? They're both the ways you can solve it, but there's steps, basically, you can say. Number 1 is just basic subbing in. Just sub it in already. Just sub it in. If you want to find the number it's going to approach, just sub in the value, x value, that's approaching. Alright, the input value, just sub it in. So for example, if there was a limit that was like x as x input approaches the value 2 in the function x plus 4, x plus 4, what does the function do? Alright, what is the function approach? Well, we can just sub it in and we'll find out that as x approaches 2 in the function x plus 4, the function approaches the number 6. That's basically it. That's simple. Now, that's subbing in. That's very basic. But sometimes we may have the instance where it's like limit as x approaches 1 in the function x minus 1 over x squared minus 1. Nice, right? Now, we can just sub it in. Let's try subbing it in. 1 minus 1 over 1 1 minus 1, which is 0 over 0. Now, 0 over 0 is not a good answer. Why? Because that's undefined. 0 over 0 is undefined. There's nothing. You can't solve it. It's unsolvable, basically. So if you get 0 over 0 when you're doing limits, check again if you factored it correct. You gotta factor it. I'm gonna show you what factoring is, but make sure you factor it, right? I'm gonna show you what factoring is. What really happens when this is 0 or 0, right? Well, 1, you gotta factor it. Or sometimes this might actually happen in a function where if the function is not a continuous function, right? Let's say we have a function which is a step function, right? And it's like this. Okay? Now, we can see gap, right? We can see, like, if there was a value, let's say this was 3 and this was 4, right? Negative 4. And this was, like, 1 and this was, like, 4. Okay? Now, from this range, this domain, there's only values from -3 to -4 and 1 to 4, right? So if I give a limit, what would happen as x approaches 0 in this function, step function? Well, there's nothing here, 0. So that's not continuous, alright? There's nothing there. That means it would return undefined. There's nothing there. It would return 0, 0 maybe, alright? There's nothing there. That means there is no real answer there. Okay? Just get that. That'll be very important later on. So if you get 0 on 0, 0 over 0, here's what we do. We factor it. Alright? We factor it. Now that's pretty simple actually. Factoring. I mean, that's like very low level. I mean, low level factoring. It's not that complex yet. So let's just factor this, right? X minus 1 over x squared. No, wait, that's a bad x. X squared minus 1. Well, that's x minus 1 over x plus 1 times x minus 1, right? These two cancel out. We get 1 over x plus 1. I mean, yeah. Right? Now here, all you have to do is now you check. Now you have to check if is that the simplest way. Is that the simplest you can factor it? Can you not factor it out anymore? And now look, by the looks of it, it looks like you can't factor it out anymore, right? Then now you can sub it in. Now try to sub in 1 over 1 plus 1, which equals 1 over 2, right? That's not 0 or 0. See, that's the true answer. Okay? This is the real answer. Okay? So what's that saying? What is that saying actually? That's saying as x approaches the value 1 in the function x minus 1 over x squared minus 1, the function approaches the number 1 over 2. Okay? Great. So, factor it. Factor it, factor it, factor it. That's very important. Now, let's solve some problems, alright? Let's say we have a problem that says limit of limit as x approaches 2 in the function x squared minus 4. That is actually quite simple. Let's first try to sub it in, alright? Let's see if something goes wrong. That's just 2 squared minus... That's just 2 squared minus 4, which is 0. That is a real answer. That's a valid answer, alright? It's not undefined. That's a real answer. That means in this function, in the function x squared minus 4, as x approaches the number 2, the function approaches the value 0. Okay? So that's this one was a very simple one, right? No factoring required, just simple substitution. Now let's say we have another one. A limit as x approaches 3 in the function x minus 3 over x squared minus 5x plus 6. Now let's sub it in, alright? Let's sub it in again. 3 minus 3 over 9 minus 15 plus 6. 9 minus 15 plus 6, that's, oh wow, that's 0. 0 over 0. That's not a good answer, right? That's undefined. We can't really do that. Alright, we can't really do that. So let's just factor it out. Let's factor, alright? Let's factor and see what happens. So let's factor x minus 3 over x squared minus 5x plus 6, right? Now, what this looks like a simple factor. I mean, I think the roots are x minus 3 times x minus 2. X minus 3. Now, these would cancel off, right? That means this would become 1 over x minus 2. Okay, let's just sub it in now, right? Let's just sub it in 3 for x here. 1 over 3 minus 2, which equals 1 over 1, which is equals 1. Nice. Boom. No bad numbers there. No undefined things. That means it just equals 1, right? So, as x approaches 3 in this function, the output number would approach 1. Okay? Nice. Now let's step it up a bit. Let's get a bit harder now. Let's get just a bit harder. Not too hard. We'll get the hard ones later on. Limit as x approaches 1. The function 1 over x squared minus 1 minus 2 over x to the power of 4 minus 1. Let's just try to substitute in, let's say. Now that's just 1 over 1 minus 1 minus 2 over 1 minus 1, which is 1 over 0 minus 2 over 0. Well, those are both undefined numbers. We can't do anything here. Well, actually, no, we can. We forgot a factor, right? Let's factor it. Let's go. Factor is coming in handy. Factoring. 1 over x squared minus 1 minus 2 over x4 minus 1. Okay, let's expand this. Which is 2 over x plus 1 times x minus 1. X minus 1. I just need some space. Minus 2 over x to the power of 4. Oh, wait. Well, let's factor x to the power of 4 minus 1, okay? That's that one. I'm pretty sure that is x to the power of 2 plus 1 multiplied by x minus 1 times x plus 1. Okay? Great. Now, I need to subtract them. So they need the common denominator. It seems this one's missing here, so I'll just multiply that over there, which will get me... Oh, wait. Sorry, my mistake. This is supposed to be 1. My mistake. Now, let's put it there, alright? Let's let me just simplify a bit, which will give me x squared plus 1 over x to the power of 4 minus 1. Well, this is minus 2, which is x squared minus 1 over x to the power of 4 minus 1. Okay. I need a bit more space, so I'll just erase this. Now, x squared minus 1 over x to the power of 4 minus 1. Now, I think we can factor that out a bit more, right? That'll become x plus 1 times x minus 1 over x to the power of 2 plus 1 times x plus 1 times x minus 1. These will cancel out, which will result in 1 over x squared plus 1. Right? Great. Now, that's great, right? That's a great number. Let's just take this and put it over there. Moving back to spot. Erase all this. Now, let's just factor one. Not factor. Let's just sub it in, okay? Let's just sub it in. 1 over 1 plus 1, because 1 squared is just 1, which will get 1 over 2, which is a valid answer. Okay? It's not hard at all. Solving limits. You just have to get the hang of it at first, alright? Just have to get the hang of it. Later on, we'll do a hard problems, alright? I guess that's enough problems. 1 over 2. You have to understand, today's video was about understanding the definition of limits and basics of how to solve limits. On the next video, we'll learn what limit laws are, and we'll go a bit in depth, alright, in limits. Okay? So,